Hello YouTubers. In this video I will talk about Siemens data blocks. What is data block? The name itself points out to the block of data, or block, where data are stored. So, data block is used to store, or save process values, that are written during the execution of the program. If you open a data block, you will see a big contrast to any function, or function block. It contains only tag declarations. There are no networks, nor instructions. Only a table, very similar to the Excel sheet. There are two types of data blocks: global data blocks and instance data blocks. What is the difference between these two types? Global data block, as you can understand from name global, it is a data block, that it is not assigned to any code block. The values of that type of data block can be accessed from any code block. As you can see, I just accessed values of global data block in the OB1. The structure of this data block can be freely defined. I can add or delete tags freely. I have added couple of tags into global data block. Another type of data blocks are instance data blocks. These data blocks are assigned directly to the function block. For example, this data block is assigned to the function block FB1. That type of data blocks are created automatically, on the first offline call of the function block. They are generated by the system. I will create function block, and on the first its call an instance data block will be created. This function block is for control of the valve. It contains some status and control tags in the static tags section of the block interface. The instance data block is automatically created by the system on the first call of the function block. As you can see, the structure of the instance data block is the same as the interface of the corresponding function block. The structure of an instance data block cannot be freely defined. I am not able to add any new tags. Insert row or add row are inactive. Instead of trying to add values directly into the instance data block same way as into the global block, instance data block is determined by the interface declaration of the function block. I do add some values into the interface of the function block. After adding some new tags into interface of the function block, an error mark at the instance data block shows up. The structure of the instance data block has been changed and it needs to be updated. Instance data block contains exactly those block parameters and tags that are declared in the function block. But some instance-specific values, for example, start values of the declared tags can be freely defined. For global data blocks, PLC data types as a templates can be used. For example, let's create a template for valve control. Here I have created a simple PLC data type for valve control. I can add this template into the global data block directly. I can even create an array of these templates. With an instance data block it is a bit different story. I need to add this template into the interface of the function block, as it is not possible to add any tag directly into the instance data block. How to access data values in the data blocks? Well, there are two different access modes, data blocks with optimized, and data blocks with standard access. Optimized data blocks are new feature for S7 1200 and S7 1500 series CPUs. That type of data blocks has no fixed defined structure. In the declaration, data elements are assigned only a symbolic name. There is no fixed address within the block. Values are accessed via symbolic names only. So, as you can see, I have assigned the value to the tag, by using symbolic access. Now I will try to access tag by its address. Tag access by the address is unsuccessful, as data blocks with optimized access have no fixed defined structure. Another access mode is data blocks with standard access. These data blocks have fixed structure. Here you can see column, named offset, that determines the fixed structure of the block. The data elements are assigned both a symbolic name and a fixed address within the block. Data values can be accessed by a symbolic name or address. Data blocks with standard access are tailored to one-word limits. It means that they always occupy one word, or a multiple thereof. Tags will be automatically added to the data block during compilation so that the block fills the space to the next word. It is kind inefficient. You can switch between optimized access and standard access via properties of the data block. At first, I will switch from standard access to optimized access. Right-click on your data block with standard access, select properties, and then attributes. Here you can see the access mode of your data block. As mark is unchecked, it means that data block is with standard access. Check the mark for the optimized block access. The offset column is gone, and the block is with optimized access now. Let's switch back to the standard access. The procedure is the same, but attribute optimized block access must be unchecked. The offset column is back, but compile of the block must be performed. Data block is with standard access again. Let's take a look at the setup of optimized block. Here you can see S7-1200 series setup of optimized block. On the left side there is a standard block. As I mentioned, standard access are tailored to one-word limits. So, if your tags are scattered, then there are empty gaps in the block added that increase the size of the block. In optimized block there are no data gaps since large tags are located at the beginning of the block, and smaller ones at the end. Here is the setup of S7-1500 series. Again, no gaps are formed since larger tags are located at the beginning of the block and smaller ones at the end. Very fast access is granted, as tags are stored in a way so that the processor can directly read or write all tags with just one machine command. Boolean tags are stored as byte. It enables faster access as controller therefore does not have to mask the access. The architecture of the CPU supports little endian sequence, and always access 4 bytes. In the online mode, there are various different options for editing data block. By the help of these functions, direct access of the actual values of the tags is available in online mode. Actual values are the values which the tags have at the current time during program execution in the CPU work memory. If you go online, then actual values can be modified directly at the data block. You can create a snapshot of actual values. Snapshot values can be loaded back to the CPU. Also, you can save snapshot to start values of the data block. After finding out that your saved start values are the best as process set points, you can load them all at once to the CPU. There is a possibility to load the data block without initializing it. I am about to change the structure of the data block, and later I will load it to the CPU without initialization. That were the basics of the semantic data blocks in the TIA portal. If you find this video useful, please do not forget to like it, and subscribe to the channel. Thank you for watching and happy coding.